Reducing carbon dioxide in the air. The Earth's atmosphere today has a concentration of carbon dioxide nearly 50% higher than just 100 years ago. This has come mainly from our use of fossil fuels and is the cause of climate change. See our linked video. Here we consider two ways to remove some of this carbon dioxide from the atmosphere: plant growth and carbon capture. Plants capture carbon dioxide during photosynthesis. Energy from the sun splits oxygen away from water and carbon dioxide, forming carbohydrates used for respiration and growth. But the carbon that plants take in gets recycled. They respire. They get eaten by animals which respire. And living things die and get absorbed by fungi and bacteria which respire, sending the carbon back into the atmosphere as carbon dioxide. You can learn more on this in our carbon cycle video. We need to find a way to trap the plants before this recycling happens. The Earth's surface is 70% ocean, where we could grow large amounts of photosynthesizing algae. But most of the oceans contain few living things. There's plenty of carbon dioxide, water, salts and sunlight for photosynthesis and growth. However, the element iron is missing because most iron salts are insoluble, and green algae need iron in tiny amounts to build their bodies. Thus, for each kilogram of soluble iron 2 sulfate we add to the oceans, around 100,000 kilograms of carbon can be fixed, because now the algae have all the minerals they need to grow. Experiments show that about half of the cultivated algae was eaten by sea creatures, so the carbon would eventually be recycled back into the atmosphere. However, the other half sank to the bottom of the ocean and was therefore captured, a bit like the way fossil fuels were formed. Although this seems to be a good idea, we must be careful when we carry out experiments like this on a global scale. Perhaps a safer way of capturing the carbon dioxide we release is simply to pump it into old gas wells, putting the carbon back from where it came. Imagine having a big bag on your exhaust pipe to capture the carbon dioxide. Can you think of what gases there would be in this bag? Pause and think what gases are in car exhaust. You might have thought carbon dioxide, but exhaust gas is mostly nitrogen. This is because the air used to burn the petrol is 4/5 nitrogen. Say petrol has this simple formula. It needs 3 oxygen molecules to react, forming 2 of steam, which you often see coming out of car exhausts on a cold day, and 2 of carbon dioxide. But now add 4 nitrogens for every oxygen, and these go into the car cylinders and come out unchanged, forming the bulk of the exhaust gas. There will be tiny amounts of carbon monoxide, unburnt petrol, and nitrogen oxides too. So there are 2 problems to capturing the carbon dioxide. First is collecting the gases. We can't drive around with bags on our exhausts. And the second is separating out the carbon dioxide from all the nitrogen and the water vapor. We can solve the first by only trying to capture the carbon from large stationary engines, such as those used in power stations. It is expensive to separate out the carbon dioxide, but it can be done. You then have to pipe the carbon dioxide into the old oil and gas wells, where it can be stored. To supply energy for all this means that up to half the electricity you generate may have to be used for the carbon capturing process. So to summarize, to reduce atmospheric carbon dioxide, we could seed the oceans with iron to stimulate algae growth, or we can try to capture it from power stations and then pump it underground. Much better we generate our energy without burning fossil fuels in the first place.